Good day, everybody. Brian here from quantlabsnet.com. In this particular video, I want to talk about some of the key learnings that I have had over the last few days since Saturday. I've gone deep and far and wide on my capabilities with ultra low latency coding, namely, obviously, in C++. I'm going to talk about what I've been able to achieve according to the AI. So right here, these are the highlights that I want to mention. There's a particular LLM out there which will remain nameless. It's not DeepSeek. I've talked about DeepSeek in my last webinar, and its capabilities. This one goes farther, deeper, and whatnot. I'm able to co-generate ultra low latency trading systems. There's FPGA versions I'm able to develop in C++, in C, and I can go further than that, asking for things like if this is ethical or not. I can still ask for, well, how do they do it unethically and generate code for that? DeepSeek can never do that, but that capability somewhat does exist. And when you start to ask it further, it will start to give you, I don't know, pseudocode, trading code snippets of how big firms like Jump Trading do it or Jane Street do it. It's quite fascinating. So as I said, that particular will always remain nameless. Um, it's so, I don't know what the word, like when I've been doing a lot of this AI code generation for about 9 months now. I have challenged it to the utmost. I have challenged it as I can. And even with the latest, the most advanced AI out there, be it ChatGPT 5, be it um, Opus 4.1, the Anthropic Claude. These type of requests do break processing of the request. Uh, what I also notice is that it waters the quality of the code as you ask more and more from it, and it waters down the coding. But there's one LLM that seems to take it to the limit, but I still break the limit there as well because it runs out of tokens, we'll say. So I'm going to make quite possibly a special arrangement with this provider, but it all comes down to people, uh, supply and demand, and what they're capable of paying. This is not going to be a cheap operation. Um, I've already raised up my costs quite a bit on an annual basis for people who want to take this stuff seriously. You're getting into the thousands of dollars. There's no bargain herald stuff from this. So let's talk about the big highlights that I've been promised by the AI. So the solution I got a few days ago was this. The scalability of this is immense. So there's recommended hardware out there for this. In this case, it's a 16 worker thread. As you know, once you get into the world of threading, if it's going to be on an FPGA, if it's going to be via these new AMD boards, that you can do this through a cloud. I know there's solutions where you can get this in the same data warehouse as where something like the CME comes into play, but you're still going to be separated physically because you're not in the CME, the Chicago Mercantile Exchange ecosystem. And the data costs alone for the specialized data to give you that unique third party uh, uniqueness, things like satellite uh, weather systems that are really can impact trading, especially on the forecasting. Uh, Very few providers provide this. Also, this can be also said the same for crypto. I have seen the whale trading data feeds. If you're on the retail side of crypto, Bitcoin, Ethereum, if you're not aware of how this is done, you're going to lose money. the volatility and the unpredictability, unless you're sitting on this type of style of trading, you're going to lose money. I can also say the same thing on currencies, which obviously impacts Forex. And if you're a stock trader, ETF, same thing, because we're going far and deep and wide into proprietary data feeds with the shops. The HFT shops have access to, but as I said, they're in the thousands and thousands per month. It's pretty obviously to me that the CME as one of the bigger futures and options providers and exchanges out there, which are highly supposed to be tightly regulated, do play in a pay to play environment. So the more money you have, the higher your account, the more benefits you get, the more discounts you get operating on these exchanges. And there's really only two major exchanges in the world to be part of, the ICE and the CME. So that's the way it is. That's the way it's going to be. So if you have a multi-million-dollar account, you could probably get away with it as long as you're profiting. For my testing on some of these modeling, the lowest I got one for the 2-year note was an 85% confidence trading through the simulations I ran. So I'm rambling on. So let's talk about the big benefits here for this stuff. Retail is, and the dumb money is dead. I mean, I'm sorry to say that, but they're just at the whims of what these operators do on the inside, um, who I'm referring to. So some of the big benefits here, as I said, there's a 16 worker thread example I was given, including the parallel processing across multiple cores. It gave me both the type of NIC, the NIC, which is a network card, the server, and a bare entry level FPGA board you can get away with. You could probably do this under $2,000. So you can develop your own rig just for testing for under probably $2,000. The AI thing gave me that particular ones. I've checked them out on Amazon. Obviously, you can go further with the AI to learn about this. So that option's always out there. Another option is to go into the world of cloud, but you are going to be limited on the FPGA unless you're going to go through an AWS or I believe it's Azure. You'll probably pay big for that as well. So there are some options on the cloud. Big one, actually, AMD is now really heavily getting into this space, compete against NVIDIA. So now they're actually investing into cloud providers because they want to ensure that their hardware is reachable to specialists, I guess you could call it, to make it affordable um, on through the cloud. The problem is, as I said, you're not going to get access into the CME exchange. Anyways, so some of these things will include load balancing, uh, scheduling, first in, first out, minimal memory allocation. So these are all, now you can do this in the coding in C++ and C because you're essentially bare metal. You can pre-allocate a level of pools, stack-based operation. Now, I'm going to be honest, I am not technically sound to really understand how this works, but I can guarantee you when I see something where there's cash involved in the returns and the certainty that you can get from this type of trading, I'm all in. So I may look into this further, but again, this is probably the introductory high level. Let the public know that this is capable. The development of the hardware rigs is one option. Obviously, when you go into production, it's totally different for live trading. If you want to go down this route with CME, the big daddy of the whole operation, this futures and options, and I've been stressing that all year. The only way to do this really well is specifically in options. There are some strategies that I've seen with the futures as well. It's all synthetic, the call option, buy, sell, and then there's a future in there as well. So you have to really understand that market and that asset class, futures and options. Continuing on the hardware level, we can see here playing with this direct CPU timestamp counter for count ultimate timing precision. This is right again on the bare metal. This can only be done in Linux. Okay, it's not done in a Windows, in a bare bone Linux environment with less jitteriness as possible. This is the key right here. This is the key, the throughput. Um, I was able to specifically at coding examples right on the registries. Other examples provided raw pointers, really low level stuff I've not ever seen in C++. So we're talking a million plus messages per second with a sustained output. Yeah, that can be done. It can be done somewhat in a C++ only, but you definitely want to go down the path of FPGA. As I said, there are examples of coding in there for FPGA, depending upon the options. AMD's got some new NVIDIA competitors coming out that's been out for the last year or so. So it's interesting to know where we're at, but everyone still says that the FPGA is the way to go. Again, I'm no expert on this, but fortunately for me, through YouTube and the other social media, there's always people out there interested in these topics, and I can learn from them because that's what they specialize in. So I do have that fortunate um, resource available if needed. Uh, So we're looking at sub-second, microsecond latency for critical path operations, linear scalability with CPU core count. Now, the more CPUs you have, the higher the throughput. There's also coding in there for 99.9% uptime with graceful degradation. One thing I need to specify here is when you start putting in your safety checks and your error checks, that's going to add more code and the output from the AI it gets watered down. So the functionality gets lost. So there's only a couple options I can think of here is to either develop rigs that kind of do the equivalent of a simulated test or back test. I don't know, but it's got to be done to make these that go into production and live trading 100% foolproof. So the system is designed to fully utilize multi-core CPUs that can easily scale to handle millions of seconds messages per second while maintaining low latency and high reliability. Okay, so this is now the article. If you want to know that, it can be found on my blog here, quantlabsnet.com, building and deploying the best platforms for high frequency trading for ultra lowest latency. So again, the example I have looked at from a trading perspective, um, I'm looking at affordable uh, instruments with low margin requirement. In this case, came out ZT, which are two-year notes. The timing couldn't be better because of the uncertainties in the stock market and whatnot, and people may start piling into things like gold, silver, two-year notes. So this particular one was two-year note, and people go, "Well, how do you make money in that?" From the strategy I've seen, it basically will look at specific quant, very highly advanced, deep quant modeling, and we'll just basically pound the exchange over multi seconds. It's three separate layers of modeling, very advanced. I think I've highlighted one in my prior blog post or how it's done, and this is done over various examples. I think the two-year note will hit a lot of volume as things come off in a bad way with stock market. We're at that point now. Um, so this could be an interesting strategy. All of these specific instruments were suggested by AI again. So everything you can do in AI, you get a solution, you get the market outlook, and then you can get the trading solution at the deep quant modeling, along with the ultra low latency, both with a FPGA solution and a C++ only solution in a Linux environment. So here's some of the advantages here. Um, the key here is you have to have a physical location co-located in the Exchange data center. So that's what I'm referring to as the CME ecosystem. Silicon level optimization of coding. I think we're there now with the AI. Like it's amazing what you can come out of it. where it's showing you, I don't know where the data sources come from on how Jane Street does it, as an example on a 2-year note. Um, but it's there. Same with jump trading. I have no idea how it's done. So basically, you're going from thousandths of a second, which is a millisecond, to microseconds, which is a million, now into the realm of nanoseconds, the billionth. These speeds are tangible constraint dictating the length of fiber optic cables between the systems. One of the queries I found was for Citadel with their microwave technology on their latency, which was pretty close to no latency at all across their uh, network using microwave technologies. It was $1.5 billion investment between, I guess, the data centers and their research coming out of maybe Chicago, Miami, whatnot. I don't know, but this is um, how expensive it is for these big operators, these big firms. One of the things here you have to realize is that you're like this. This is not about something eyeballing like a set of charts and just using simplified trading, uh, technical analysis or fundamental. You're getting into millions of data points across many different data sets, just depending upon what you're trying to trade. In my case, my like the speed of AI is so immense that my ideas pretty well get outdated every time I query something. But I figure you want to start from the lowest level, ultra lowest level, I should say, on how the trading is done in the HFT space. Doesn't mean I can participate in it because the budget I don't have on what the large Citadels, Jane Streets have, but it's always smart going with the mindset of high frequency trading and the deep quant modeling. Because if you start to look at how retail trading does it, or a typical um, portfolio manager in one of these big banks or hedge funds thinks how it's done, or a family office, this stuff is way beyond that. And a lot of this trading and the opportunities come and go at the blink of an eye. And some of it is unethical, namely stuff quoting and jumping ahead of quotes. And at the same time, when the order flow from large retail brokers are sold back to the firms of the HFT firms that I've mentioned in the past, I have to be careful here on talking about this because of, I don't know, I just don't want to get myself into muddy territory legally, financially, all that fun stuff as well. Um, Now, another factor that the AI does address is the reliability and the determinism, predictability of this. The system must not only be fast, but also predictable, fast, and robust. But the error checking, I hate to say, you don't want it. It just adds to the risk of the performance as well, the cost of performance. So systems of fast on average has unpredictable latency spikes because of the jitterness, which is unreliable. Has to perform with a deterministic, repeatable timing and handle failures gracefully without crashing the market disruption. So what I found was a lot of the firms, or the AI told me with these iceberg orders and specific types of iceberg orders, they do that in a way so that they get away with these type of trade, ultra low, high frequency trading. But what they worry about is the market impact. So they have to do this in slices, in small but big orders, and usually they go through a dark pool. But there are data feeds out there that watch these dark pool events and market data. Um, but they're very expensive. Okay, so those dark pool do exist. A good example, if you look at the third party uh, uh, Open BB solution, I remember they do have some data feeds there that are specialized in this. but also I do believe that CME have their own and some of the other uh, providers. Deribit's a good example to watch what happens in the Ethereum and Bitcoin world, because Deribit's considered like that's a great exchange for where these operators participate in. I've known that for years. So if there are some specialized Deribit feeds as well, just as an example, not just the CME or the ICE as well. So here, as part of my Quant Elite, I put up a specialized C++ project. It's called Ultra HFT 5 million per second uh, set of code. Okay. Um, Obviously, I'm not going to show that. There's four different versions of this, but the specific one I picked was this one that has this high throughput of messaging, just to give you an idea how the coding's done. And again, that's available on my Quant Leap membership. What I'm going to be doing now is I'm going to be talking to people to see how serious they are. I'm not going to waste my time on people that just want to go out, collaborate, quote unquote, collaborate, or go out for a coffee and pick my brain. I don't do that. Okay. My time's too valuable. I could be putting my time into this type of research and deploying these kind of uh, coding projects into production at some point. Just to give you an idea. So this application that I'm talking about um, had to tackle a lot of the challenges. And as I said, there's only one LLM out there that I think that could handle it to code up this thing. Uh, DeepSeek, forget it. Unless you get some specialized DeepSeek model I don't know about, or an LM version I don't know about. ChatGPT can't do it. It's, I mean, unless you pay enough tokens. The only one I think that will be closest would be the Opus 4.1. But when you compare it against this other LLM that I'm not mentioning, doesn't compare in the quality of code. That's the closest I've seen. That probably what the institutions and the firms are using. And again, that's my trading edge. I'll be going into my grave with that. And it's not Chinese and it's not US. Okay, so we'll leave it at that. Just an example, I just got word there last week. There was one from Switzerland. Another one just came out from the UAE. So who knows where it could come from? So the idea here is to achieve a throughput of over 5 million messages per second while maintaining a microsecond level latency. So these are some of the examples. This is just one example. I'm able to code up how it's done. Okay. So this is just a high level guide, but to get the source code, obviously you got to join my thing. And I get comments from people. Oh well, this is all BS. This is all blah 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 blah. Hey, you don't have to watch my stuff. You don't have to participate in any of this. No one's asking you to. But I can assure you, for every person that doesn't like it, there's probably going to be 10 to 20, 50. I have no idea how many people are interested in this. So yeah, there's a lot more people in the so-called haters out there. It's immense. But we're in a world now where we're dealing with the AI, the way it's evolving and how fast it's evolving. It's so different when the combustible engine came out, and then there's a big crowd of the horse and buggy people resisting this or fighting it because their career or their job was threatened by it. So this is the same idea we're dealing with. This is so transformative for humans, where AI is able to basically level a playing field, peel back a lot of uh, secretive stuff that a lot of industries have, and it puts a lot of these industries and it threatens them, it threatens their livelihoods, and it threatens their industries as well. Because if you know how to prompt AI, you know how to look for the right LLM for what you're looking for. Yeah, it does level the playing field. And as I said, I think I've seen the most advanced. I personally thought DeepSeek was the most advanced. No, 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 no. There's other LMs out there that I don't think the world needs to know about what's even more advanced. Okay, so what we're dealing with is a mechanical sympathy. Uh, let's see what we got here. So here's some of the techniques here. Again, I mean this is all new to me on the hardware level. Uh, it's a hardware profile, as I said. So you get multi-core CPUs, deep cache hierarchy, NUMA, non-uniform memory access architecture, and fast interface. I have seen multiple now examples via these AI versions mentioning the bypass on the Linux kernel. Um, so that is a major source of latency and jitterness. Okay, so when you're dealing with these specialized systems, you can bypass that, and these are critical data paths, so you can get around that. And again, you're operating on a bare metal, right on the processors and the CPUs. So you're communicating directly with the hardware, and as I said, the network cards, NICs, and those. There was one that was suggested, but I know about that brand anyways. But um, you can, as I said, develop a home built rig for under probably $2,000. Just play around with it. And as I know, with the cost in the AI, where people are building out their own AI rigs, I think we're at a point now where you can spend a lot of money on these GPU cards and videos and whatnot. And the way it's been going with these the competition is getting more fierce for the LLMs um, providers. We're getting more fierce out there, and it's getting cheaper and more affordable as well. That's just the way it was in the early days when the combustible engine came out and the Model T came out from Ford. And there was 40 new providers out there within 5 years, 10 years. And that industry is always a great example in the tens, 20s, and 30s, as well as a great example where we are with AI. It's very revolutionary. And on the back end of that, you have robots, the humanoid robots. We are going into that very transformative new phase of humanity, I guess. So what we have here is a standard kernel network for simplicity, uh, highly optimized. And the idea here is to reduce the kernel overhead as much as possible. I have seen and I've heard firms will download the kernel, Linux kernel, the raw Linux kernel, right from kernel.org and customize their own Linux kernels. Okay, so can AI do that? Probably. Is it worth going down? Probably not, because that's where the FPGAs come in play. Okay. So here we're also from the software perspective, the programming perspective, we're doing zero copy, minimal memory operations. As I said, I'm going to be doing this very high level topics in a webinar. I cannot sit here and teach people, go into specifics, and even on that technical know how. I can't do that at this point. These are all unmentionable topics I've known about, but the specifics to understand them, these are the new areas I'm put my energy into. So if people are going to be expecting me to do it through a media clip, on a short media clip, you're insane. If you expect me to teach it to you in an hour, you're insane. Everything comes down to rock solid work. Um, at everybody's level, I can't provide these solutions. Okay, but there's a huge demand for this, no doubt. Okay, so now let's get into the component breakdown on the software level, with the data flow as well. Again, this is very high level. So the big one is the market data ingesting. Okay, there are a variety of ways to thread and listening to various things on a network that's provided by an exchange, CME as an example, Chicago Mercantile Exchange. You're going to get it in raw market data packets. Uh, you're also going to be most likely working in fixed protocols. So that's in itself very difficult. I have coding examples of fix as well in these environments. Okay. As an example, let me just talk about a strategy that I saw in coding. I don't know. I don't remember if I posted it, my quant lead, but just as an example, if you're looking at option analysis, as an example, um, Vega, or which seems to be the key one, or Gamma, there are now parallelization on the models in parallel dedicated to these specific each Greek element. It's crazy what I saw. And this is only provided by this, to you, unknown LLM. But this is the level we're talking, okay? And there's secret sauces that come out of this as well. Um, so we have here these packets got to get time stamped. And then the other one that is one of the most popular topics that I didn't know anything about. with this thing called a lock-free ring buffer in various worker threads. Okay, it's very advanced coding. Um, One example I can give you on the benefit on this type of coding, yes, you can get specific models, but there's a whole level of infrastructure that has to get developed. But the coding that's involved here is worth, this is what the AI said, is worth in the billions. Okay. So this is a level of probably, if you want to look at the world of investing, this is the most lucrative style of investing out there, period. I mean, when you look at these firms like Jane Street, Point 72, you can see why they're paying the highest paying internships in the world, where they're paying these students for a full year 150,000 and up, like 20,000, $30,000 per month. It's crazy what they pay these students, but these students are beyond geniuses, beyond geniuses. Okay, that are coming out of probably the best schools out there, MIT, Massachusetts Institute of Technologies, and the like, out of the states, and some of them UK, and I'm sure there could be one out of Switzerland that I could think of, or India. I don't know, but these are very, very high level schools. Okay, so if you're coming out of those schools, yeah, you will be taught and exposed to things that us little minions will not get access to. But we can learn through AI how it's done. Okay. So here's the strategy engine and model implementation. So one of the examples I provided in my Quant Leap, in there, it gives you an architecture file structure on what is put into these type of systems. Um, and one of them will include a strategy engine and a little custom uh, strategy dedicated to this whole entire system. But again, it's 100% software. Okay. So here's how it works. So there's the order book is involved on the bid and ask, obviously. There's a set of algorithms within the strategy engine itself. There's going to be proprietary logic as well. This is important to understand. It's one thing to understand that there's these very specific models that have been developed, and they're basically kept under wraps by these firms that they don't want people to know. Well, in the world of AI, that gets exposed, especially if you know how to prompt this stuff. And one of them I'm going to get into in a minute. It's pretty popular. I've known about this. But the other thing is that's very secretive. You can have all these models, but it's parameters. The value of the parameters is that's a secret. And there's going to be trigger points on when you're going to do the entries and the exits on these. Okay. So that's another thing that needs to be considered. Okay. So there's going to be design patterns. There's also going to be data flow patterns as well. Um, there's going to be looking for things like hidden orders. And as I said, that's all due to firm trying to hide those big, big orders. They have no choice. They have to put out these big orders, but they have these different techniques to use basically in a dark pool. And they're going to try to do it in a way where the model will detect it and sense it and know what to do from it. And there's also going to be other models that will try to counteract and minimize that impact. So and when you query these LLMs, it goes at both levels, and you can see examples. And then at the same time, you can ask for uh, the code, suggested code, and it'll this particular ALM that I've not mentioned will actually give you the values, those highly secretive values, the parameters for some of these models. So out of this, when it says proprietary, that's where the proprietary comes in, because a lot of these firms will put a lot of research into taking a model and modifying it to their uniqueness. That's what's the proprietary value at these firms. So some of the more popular modeling will be SABR, where they calculate the volatility, the surfaces, and identify the pulp parity I've talked about, the inefficiencies or discrepancies in the market. That's what these firms are looking for. Okay. Um, these are dynamic. And the key word here that a lot of people never talk about is self-adapting. These models are self-adapting. Okay. So this is just another way of adjusting to the market conditions. It could be based upon volatility, and this can be done at a microsecond level. Okay. Um, and here's what I was talking about on the option front. Okay. Okay. So here, before any order is sent, this is the risk management now. It must pass through a risk check, a rigorous one. So if you have an overall portfolio with all your risk modeling, you got to calculate your delta, your gamma, and your vega. Again, those are your option Greek. You got to know your exposure, how it can negatively impact the portfolio, and automatically trigger those hedger trades as well. That's where you get these combined uh, shorts and longs on specific positions using these Greeks. Okay, these ones right here, and you're trying to limit that. It also calculates the metrics on the adverse selection probability right here. Okay, in microseconds. And the fascinating part about um, this particular LLM, what it will do is to say, this is the industry, these are the metrics that are needed to measure against to beat these other. So it's a nuclear uh, arms race when it comes to the technology, without a doubt. And it will suggest here are their targets at the microsecond, nanosecond level. And then you could say, hey, okay, we know that that exists. Try to put it up in a way, again, using AI, put it up to beat that. It's crazy. And this is on recent trade flow to adjust the quoting strategy. I think things are so advanced now, where you have models, you have things through technologies like RAG, and where you can query models and bring back new models while it's trading. I think we're at that level, and that's where things are moving to. And as I said earlier, I've seen some of the modeling that I've gone through where it's three layers. So again, you got your strategy engine, your risk management, and now your execution level of algorithms on top of that. So again, this is level at microsecond, nanosecond level. So we'll look at the recent trade flow, okay, on a quoting strategy. There's yours, and you can use custom trading data feeds from the exchanges and other providers. Very expensive to look at, to investigate, to see how that works. So out of that, you get your execution engine as well, and know how to properly uh, send out the order. So here, as I said, the exchange native protocols fix and sending it through their network interface, okay, within their environment, through their data warehouse, through their ecosystem. So that's how you participate in the CME. Very expensive, very, very, very expensive. In the thousands per month, just on the data feed alone, you'd have to have a multi-million-dollar account to do this. Okay. So here's how basically the feedback loop. You get your market data, the model, execution, and risk, and then the market data again, and then it loops back in. That's basically how it risks. So the secret sauce of this is not in the single algorithm. It's a layer of algorithms. Okay. And that algorithm is not going to be perfect, but it needs to self-adapt to what's going on in the market and what's happening with the, call it, negative market data impact or the market impact that it sees. Here we, at the same time, we have to make sure that there's this orchestration of modeling, algorithms, and coding to develop in a high speed and as perfect and most highly reliable as possible. Okay. So essentially, you can see here, this is literally, literally battlefield. Okay. So what can we do? So here, this is a typical project selection. Okay. So here, this is a example that's available on my Quant Leap programming. And as I get more into this, and then hopefully if I can find a way to get access to this particular LLM in a way where it doesn't break the tokens, I'll gladly pay for that. But that's why my membership's going to go up exorbitantly because of this. It's a very expensive venture. Okay. And right now, if you go on, you'll see it. But I prefer if you talk to me first, just to really understand your knowledge in programming and knowledge in trading, because it's not my job to teach people how to do basic Python or basic C++. And same with the trading as well. I would expect you to have a certain knowledge before you come into this, and to really understand it, and try to realistically um, set your expectation as well, um, because this is important to know. Okay. All right. So here's the CPU stuff. I didn't realize that this put this out there. The nice thing is I'm now putting in citations from the AI itself. Okay. So you can dig deeper. Okay. So this is a basic level, entry level hardware system. So let's say you want to do an 8 core, uh, dedicating specific cores to specific tasks and eliminate context switching overhead. Okay, so there's your goal. So, as I said earlier, as one of the examples for the specific target on a specific core, let's say you want to dedicate Greek analysis, and I've just highlighted just some examples here: uh, gamma, vega, and delta. So, what you're going to do on each core, most likely you could ask for each core to be dedicated to that analysis in parallel. And I've seen coding examples generated by AI to do that. So this is what we're dealing with. So obviously you got to deal with a modern CPU, high clock speed as well for each instruction. Now, well, let me just go through this just on the hardware front, okay? Because it's really important to understand. And I think because of the pace of AI and basically the pace of what NVIDIA is pumping out in terms of hardware, GPU, and all that. And now you're getting the AMDs coming in to do the same thing. So here, this is going to go over my head. Let's go like that. One thing I know, even in my ebook that's available for free, if you go to my quantlabsnet.com, you can ask for it, where you get this SIMD, single instruction, multiple data extension. I believe you can do that in C++, right from the compiler level, I believe. Here we have AVX. AVX2 allows CPU to perform the same operation on multiple data points, 8 floating point numbers with a single instruction, providing massive performance boosts for numerical calculations. So there you go. Those are your citations right there from AI itself. Everything I do is so AI. I can't explain it. Now, on top of this is all new to me. Used, multiply, add further speeds this up by combining two operations into one. Who knew? What I will say with these hardware, from what I've seen and what I kind of know, is that there's always new hardware updates coming out. So if you're just spending $1,000 on a rig, you may be lucky to get a week, maybe two, at most a month, because that rig's going to be already outdated. Because there's always going to be a new development coming from a competitor, and soon we're only dealing with the Western hardware manufacturers. Okay, uh, like the Nvidias, the Intel. Forget Intel. From what I understand, Intel's way out of it, but it's really Nvidia and probably AMD. And then on top of that, when you look at where the Chinese hardware is coming, especially in the GPU, from what I understand right now, it's about 80% of where the US is at. So we're going to get these new onslaught of processors and whatnot coming out of China. And they're probably knowing those operators, they're going to be a lot cheaper as well. I mean, that's how China does things. Love it or hate it, you can keep, even on the AI LLM level, it keeps everything in check, keep everything competitive, um, as well, because that what makes it more accessible for us minions, I guess. So continuing along, HFTP load large data sets. I've seen the code. We've talked about the throughput up to significant memory for order books and other states. 16 gig is a reasonable minimum. Minimum 64 gig. So again, we're coming back to that NUMA. Most critical aspects of low latency systems. Multi-socket or even modern single socket CPUs partition into nodes, each local to a group of cores. Local memory significantly faster than accessing remote memory, memory on another CPU node. The script checks for NUMA topology, as the application will explicitly manage memory locality to ensure threads always access local memory. So right here, it's important to recognize the fact that as the hardware gets more expensive, And these large operators, the trading firms, the Citadels, the Gain Streets, they're going to invest in this technology every couple of months for sure. And then most likely at the other end of it, their coding projects will self-adapt to the hardware, because a lot of these providers are going to provide an API to access the hardware. I'm assuming. I'm assuming. It's way too early for me to dissect this. Okay. The AI is there. You can learn it. Find that. Okay. So here, we're dealing with network interfacing. So there's a script out there that I've got that's customized by the AI through the tuning, and it's configurable, where you can check for 10 gigabyte or 25 gigabyte per second or faster connections as well. So here, it's a combination of your OS, your operating system, and your GPU, okay, or CPU. So here's how it's done, and the AI is so advanced where it gives you configuration at the both compiler level and within your own software to make the modeling core of the C++ able to self adapt to this. So again, on the project level, what we've got here is two things. This is the core. So we've got built out the scripting. Again, those are your automation scripts. In there, it will bang out a monitoring script. It will bang out a tuning script. On and on and it goes. Configuration as well. That's specialized. And then there's these flat files that can be spat out for deploying. And then, of course, you have your testing and your performance as well. That's a very high level project that I've seen. I've probably developed, I don't know, 5 different ways of doing this combined with both FPGA and C++, where it's non FPGA as well. So coming back to what I was leading into, we have here now the kernel of the OS, which obviously is Linux. So this is essential. Some of them have pre-patched real-time kernels, preempt RT real-time to further reduce jitterness. Okay, so it's like fine-tuning right down both at the hardware level and at the operating system level. Modern CPUs can dynamically change their frequency to save power. Disastrous for latency, as it can take milliseconds to ramp up to full speed. Some of the data warehouses have literally great example I've learning about AI, XAI in Memphis and how they've done it because they've put their entire infrastructure in this one data warehouse and the level of Tesla batteries that they put in for redundancy and recovery if there's something that goes on the blink. And you got to remember a lot of these big data farms that are being built out, be it from OpenAI, be it from Microsoft, Google, whatever, they take up a huge amount of electricity as well. Okay, so on the OS front, we're now dealing with memory managing in small 4K pages. Performance overhead due to large number of pages that the CPU, TLB, translation, look-side buffer. Huge pages allow the OS to use large multi page sizes, 2 meg, 1 gigabyte, reducing the TLB and improving memory processing. So when you get into this HFT, you already know what you're dealing with here. Okay. So here we're now dealing into the building tools, essentially. So I've got some examples already highlighted in my Quant Leap program. These are just examples and typical trading strategies. Some of them highly advanced. Uh, right now, the problem is because of this one LLM where I can't generate enough tokens for it, I have to work with the provider directly to get that, and I have no idea what the cost will be to build this out. It's probably going to be well into the hundreds per month. Probably, I have no idea. That's why this membership's going to get very expensive for this capability. Um, so it's going to be a combined effort as well. So that's on the Quant Leap. I don't think there's going to be anything else online like this where you can join and learn this for both either career or your own development, which let's be honest, not a lot of firms are going to be hiring now humans because AI can do all of this. AI can do all of the self-adapting. AI can do all the customizing on the hardware. And as it says, the hardware may be adaptable as well. So it's going to take out a lot of people needing to do this sort of stuff. And I think that's the future we are going. So the only way to get in this is to have like-minded people get together, but you've got to have a firewall or a paywall, keep the naysayers whole out, because they're the ones who are going to really drag this type of operation, this kind of community behind. You don't want to have those type of people, so you have to have a fairly uh, high price, keep people out, because the idea here, it is about a community, like-minded, and having the same mission. You don't want to have people that are going to be holding back a community like that or a membership like that. It's like going into a high-end golf course, country club, um, and they charge exorbitant amount of money to go in. Members have expectation of how um, that country club will operate, but yet if they get some jerk coming in and urinating in the plants, urinating on the golf course, or do stuff like that, the membership's not going to tolerate. And it's going to be the same thing with this type of membership. Because if you don't want these kind of people with bad juju coming in or bad energy coming in as well, and believe me, there's a lot of them out there. And I've done a presentation in front of 40 people in late July, I believe. All it took was two people to be negative, and that pissed me off where I didn't want to do that, kind of meet up again. And guess what? The majority of those people pay the price. So the online presence, um, this is how it's going to be. Because, like, it doesn't bother me. I just can't be bothered to go through an environment in a space, set up everything. They come in for free, expecting stuff for free, and want to steal the results that other people are willing to pay for. And put, you know, I can complain all I want about it. It's no point, but you get the idea. All right, so these are the build tools. We have here the modern C++ compiler, PCC. It will, depending upon the AI, what it generates, it could be 11, 17, 20. I've not yet seen 23, but the code will adapt to whatever version of C++. You can specifically say that with, let's say, 11, obviously going to make the code less efficient as well. There's some of the newer C++ features that will take advantage of the things that you're trying to do. So the key here is CMake file, the build process, and Ninja for its high-speed parallel uh, build execution. So that's probably a tool I've never heard of, Ninja. Maybe what can talk about that. I don't know. Pcache, which again I've not heard of, caches compilation results to dramatically speed up subsequent builds. So this is a huge operation. I mean, this is not something for the faint of heart. Okay. Um, Also, we have here these different libraries, this libeigen3 for linear algebra, useful for model calculations, NUMA for the NUMA, NUMA control to pin threads and memory to specific NUMA nodes. Um, Sometimes I might include these ones. This is I believe this is ZMQ, the 0MQ, the SQLite as well for data storage compression, non-critical path tasks like logging or configuration loading. Other things like monitoring and debugging tools, Linux tools, generic. So there's the performance profiling tools. These other ones here, HTOP, Systat, observing the NUMA placement, system load, and other performance metrics. Then there's Valgrind, GDB, strace, memory debugging, general debugging, and tracing system calls. Again, if you're learning about this for career, I mean, do the schools teach you this? Like the high-end trading, not trading schools, but universities at PhD level in computer science or quant modeling, physics? I don't know. I have done AI generated with my own commentary on it, where there seems to be this massive gap between university and what they're putting out. even at a PhD level. And when they go into these firms, there's this major gap between what they need to know and what they're coming out of school for. It's not the student's fault, but I do think now where there's literally thousands, probably 20, 20, 50, I don't know how many thousands per internship at these firms. Yeah, you got to know this stuff, and the only way you learn it is through my kind of membership or on your own. But the AI can only do so much, as far as I can tell. I mean, it's getting more advanced. You probably learn AI on your own. That's the problem. When you're doing it on your own, it becomes a problem because you're not going to have people within a community behind a paywall setting things straight, or there could be experts come in and say, no, do it this way, that way, this way. Okay. That's what a community gives you. AI can't hide that no matter what. That's the general human element of a human based community that AI can never provide. Um, so the build process, the high performance engine. So again, the only language that can do this at this point is C++. Um, I have seen commentary on Rust. It's getting there. The problem with Rust, it's not being adopted by the firms and the standard firms. The reason they don't do that is because, well, their ecosystems are going to be, and their frameworks or libraries are going to be out there for decades. Okay, like since the '80s. If you look at Renaissance Technologies as an example, so I don't think these firms are going to change their frameworks in C++ anytime soon. I don't think they will change out their hardware and just their whole processes. So C++ is going to be here to stay. And I think from a career perspective as well, you want to stay in the world of C++. I mean, it's different if you want to, you know, go against the grain. You want to do something like C++, I get it. Or do it in Rust, I get it. Um, but I think it's got a long battle for Rust. Hearing good things about Rust. There's always going to be people out there, as I said, that will want to take a whiz on the plants in the country clubs. Those kind of people always exist. And to be honest, there's some of them that rebel for the trailblazers for the next generation, whatever comes out, right? So they're kind of important in a way, uh, but as long as they're productive and healthy minded for other people to benefit from. So again, compiling the code is tuning the C++ in the executable, instructing the compiler to perform aggressive optimization tailoring to our specific hardware. So, yeah, that's one of the things that needs to be understood is you're not just tuning the CMake file or the build process, but you also have to figure out on the compiler level on the different optimization techniques to do that. This is all very complicated. There's no ifs, ands, or buts about it. It's not an easy process. That's why these firms highly protect their trade secrets and whatnot. But I do think that over time, AI is peeling all that back. But you can see the amount of work involved in this and the amount of customization or the proprietary trade secrets are critical to keep those firms ahead of the game. So C++20 has concepts, ranges, improved concurrency primitives that could lead to cleaner and more performant code. So that's why you don't want to stay stuck in 17 or 11. Okay. One of the things I have suggested is there are other um, commercial libraries out there, frameworks in C++. From what I understand, talking to people in this industry, they don't use third party, not a lot. They may use a fix engine, but why? Why? Because now AI can do everything. Um, AI can just do everything. And if you know how to prompt, you know which LLM to use, you can do it. No questions asked. I've seen it. So the CPU architecture detection. Actually, let me just stop here. Again, this article is developed by an AI. Okay, that's how we're able to peel back this stuff, right? So here, and not just that, but the AI is smart enough if you know how to prompt it to give you the proper recommendations and the pros and cons of each and what to pursue. That's how advanced AI is. You just got to put the work in to really understand it, and the ones that do very well in this space. But the unfortunate problem is that AI is so advanced and so competitive. whatever you maintain as your trading edge will be either eaten away or out innovative because of the AI or some hardware manufacturer, some trading firm has come up with something better. It's just the way it is. That's why they call it the nuclear tech arms race. Okay, for this space. Uh, so clever to attempt to compile a small piece of code using this AVX2 or FMA. Okay. Uh, we add in these configuration flags, okay, in the compile process to generate code specifically optimized for the specific CPU that you want compiled on. Unlocking available instruction sets, again, there's a citation. AVX isn't available, it falls back to the older SSE 4.2. So here's some of the specific flags you can use for optimization. O3, EN debug, fun, fun roll, I like that. Loops, FLTO. Okay, I'm not going to get into those, but this is what we're dealing with. Again, for the mathematical, we've got here locate all the necessary libraries, NUMA, eigen, and that they're correct. Okay, and then there's the definitions within your coding for eigen no debug, eigen don't vectorize. So there's your testing code, and then there's once you're happy with it, you go into production. Okay, using all these different tools. Out of that, again, comes out your scripting, your make file, um, you have different build releases. I've been told, and I've seen job descriptions where they have people all they're doing full time is building out CMake files, configuration files, just for the build process. It's not involved. Okay, so here we're using CMake, using this Ninja to run compilation in parallel. Something new. I've not heard of that. Using all available CPU cores for maximum speed. And remember, that's just on the technical. Then you have to worry about your trading strategy algorithms as well that are specifically coded to run in parallel. Very key to optimally take advantage of this. So again, we have the scripting as well, more raw direct approach, calling the G++ compiler with a list of flags, useful for fine tuning, experimenting with compiler options without in direction of CMake. One of the things that I do is, and I think this is important to understand, is when you start to break out your coding into modules with header files, other more object-oriented concepts, this is where you're starting to hinder against performance of these very specified type of systems. One thing that's not mentioning is metaprogramming with a template. That's probably one of the lowest style high performance at the coding level. You've got to be very specialized to do that, and a lot of firms want that. And it comes down to, well, do I use FPGA? Do I do metaprogramming only? I don't know. This is all new to me. I can tell you, but this is why some of the coders out there paid $1 million plus or into the millions to know this sort of stuff. And really, only C++ has the capabilities. Rust may be able to do it. I can't say. Okay, but C++ isn't mature enough where it has the third-party libraries that I've been mentioned here for the hardware customization on the compilation. So here, build directs shell script. I got an example again. That's part of the project that I've got. This gets more and more advanced with the trading in mind, the modeling and whatnot. We have here the compiler with explicit list of flags, useful for fine tuning and implementing and experimenting the different compiler. I just went over that. So we have here the scripting where it has to be intelligent for this object dumped to to disassemble the final binary and grep for specific SIMD instructions, mnemonics like FMA, AVX, providing concrete proof that the compiler has successfully vectorized the code. This is why these people are paid in the millions. And this is just on the technical side. This is just on the coding side, on the compiler. We've not factored in the trading strategy algorithms themselves. Here we go. This is how we do it to get our transparent, our throughput of 5 million messages per second on that engine. So this is again high level, and there's many different ways. This is one example. I'm just trying to show you the complexities of what's involved. C++ code, functional, albeit simplified representation of ultra high performance trading application. Okay. Uh, so this is the core design philosophy. Okay. Separation of concerns. We have a producer thread mimicking the network data arrival with a pool of worker threads handling the processing. So those worker threads are going to be the ones that are going to be doing the parallelization and the Greek analysis and all that stuff, as an example. We also have to worry about your data structures, have to be cache friendly. Again, all of this is generated by an AI. It's not like I picked up a book and learned how to do this and just spit this out. AI is teaching me how to do this. And in this case, in this particular article, you're getting citations to back it up. The other thing a lot of people talk about is this locked freedom, critical communication path between the producer and the consumer using lock-free buffer ring buffers to eliminate contention, explicit hardware control, threads that are pinned to the specific CPU cores. Outside of assembler, the only other one that I know of that can do it is C. Okay, so that's the next level up, the Linux level on the bare metal. Again, I don't know what Rust does behind the scenes. I don't even know what C++ can do. But I will tell you, if in the coding that I've seen so far, is using C raw pointers in the C++ code because it can do that, and then the compile process it will optimize it specifically in assembler for uh, the specific CPU cores. Very critical to know that. So then we also have to deal with these newer memory is allocated on specific NUMA modes. So every single hardware board is going to have specific specifications that you have to tell not just the coding itself, but the C++ optimization, and to go through the process and all those tools that have been mentioned at the latency level. And on top of that, making sure that your operating system gets rid of as much jitterness as possible. Crazy, man. So here's the handling the messages per second on the lock-free ring buffer. Okay. Inner-outer communication lock-free single producer, single consumer SPSC ring buffer. We use one of these threes for each worker thread. So the coding is going to code up very specific logic from an algorithm for your trading capabilities and what you want in the trading. But again, you can use the AI to do that. And not many AI LLMs can do it at this point. Maybe they will. I don't know. But you're going to have to pay for it. There's no free lunch here. Data structure allows one thread, the producer, to pass data to another consumer without using mutexes or other locking mechanisms that would cause threads to block and introduce latency. So again, I don't care who you listen to on YouTube or social media on an expert level. Okay. There's probably still going to be some concepts in there that, as it says here, if you're using mutexes, those are locking mechanisms, and that's going to hinder and block your latency. Okay. Again, I'm not claiming to be that, but the thing is, I'm so open minded towards it. And not only that, I'm willing to spend as I can afford it from this membership will get me to where this point is and also share the code as well as all of the end to end with algorithms for trading specifics for the trading conditions that will take advantage of this. This is what you're getting in this membership. Name me one that does it and takes it to this level. Okay. So again, what we're looking at is atomic operations, careful memory ordering. Okay, that's another factor, new to me. So we have this write index, consumer updates a read index. This is all embedded into the code that was generated. I posted on my membership. And guess what? It's going to change again as I go deeper with better research and better coding results. Key is that only one thread ever writes to each index, eliminating race conditions where you have a C++ atomic library providing those necessary tools. Memory order relaxed. Use no ordering constraints are needed, offering the highest performance. Memory order release. Ensure that all previous writes from the producer thread are visible before the index is updated. Memory order acquire ensures that after the consumer reads the updated index, it also shows the data written by the producer. I didn't know about this, and it's probably going to change. And it could probably give me a different option on a different type of query. This is how mind-boggling and mind-bending we're at. Okay, so here, multi-threaded architecture. This thing, 10 threads for each dedicated rule. So depending upon how you code up your model, and let me also repeat, I've done not just an HFT quant trading model strategy. There are specific examples I provided for market making. That's where the firms make their big money, is in the market making. What's happening right now in the trading field is everyone's going on about their dividend income when they go into retirement, and they'll be all fine for the rest of their lives in retirement off of the dividend income. Or they'll live off of their property. Guess what? People like that will not have that opportunity. Why? Because right now I just read a story about how the one of the European stocks, STOXX exchanges, are now eliminating quite a lot of dividend income or dividends are being cut by many European funds, by a lot of European companies. I think that you're going to hear more about that at the U.S. level as well, where a lot of companies will cut their dividends. What does that do for the retirees? Basically, they're screwed. Property, well, we already know where the property is. Now they're talking about property collapse. So all of those income sources that you've been relying on are going to go by the wayside. So what I'm saying to you, you have to know this stuff because the next new trend in is what they call cover call ETFs. Okay, I've seen them both just being introduced this week for Ethereum. Okay, my portfolio guys are offering me this, and the providers I'm getting them from both Fidelity and from Dynamic as well. Okay, and it's all yield based, where they promise 7%, 11% return. That's what was specifically promised to me, based upon the risk I'm willing to put on or take on while I'm going into retirement, based upon volatile in a very high volatile environment. You get 11% return, whereas you can go for the 7% return. At the end of the day, what I'm saying is these cover call, basically writing the options, will be a highly dangerous venture, I think, down the line. Why? Because I mean a lot of uncertainty coming into these spaces. And not just that, it's make some like highly predictable, crazy volatility. No portfolio manager that's human based will be able to keep up with this uncertainty. The unfortunate thing is the only way to stay on top of this is exactly what I'm talking about right here. It's the only way. Through the technical and deep technical you need to know. And on top of that, the algorithms to be able to adjust on how it's done. A great example of that I can give is Ethereum. There are certain data sets that the whales will watch and will make their big trades. Meanwhile, on the other side, there's the retail trader, the dumb money, are sitting there waiting for these whales to make their moves. And then they hopefully catch it and get a return. The whales will then get out or do whatever they're doing with those big, high spiking orders and then drop off. And what happens to those trading opportunities for the retail? It dwindles away. So does their trading returns. A great example of that is the penny stock industry, with the penny stock pumpers or promoters, and they're building it up on a particular stock, pump and dump. And it's no different than the Ethereum world. And at some point, you'll start to see it across in the mainstream world, across different instruments as well. At the CME in mainstream, and personally, I predict CME is going to look there and go, "Not our problem. Sorry." So they'll have their circuit breakers, but the next day, if you were living through the great financial crisis, they always had the circuit breakers, and they initiate them because the stock, the equity markets were dropping so fast, so they kick in, the circuit breakers kick in. and ramp it up next day, and then you can go through 3 4 days of the markets getting halted because everyone's getting panicking and dropping. And when you listen to the doom and gloomers, what's going on, uh, they're only talking about the gold and crypto. It's your safe haven. But guess what? These firms are not stupid. Okay? They're not stupid. They're going to manipulate the futures market and they're going to manipulate the options market of the gold markets at the futures and the CME level. Guaranteed. And that will be manipulation. And how do I know why they're not going to do anything about it? Look at what happened in '08. Who made the money? The bankers, the insiders. Okay. On top of that, the other problem is that the senators and whatnot are in on the take. They're bought and sold through the lobbyists, the big lobbyists that represent these big firms, the big HFT shops. Okay. Their lobbying power is probably bigger than what the car industry was with the unions. Okay, bigger, I'm sure of it. And they buy up these senators in their 80s and 90s, don't even know what they're talking about. It's funny when you watch the sessions, but you got to really know what's going on the inside at the technical level I'm talking about, and at the low level market level for both the options and the futures, because this is where the manipulation will come in. And if you know it, you may be able to benefit from it. And as I said, there are now specialized LLMs that will show you how to do the unethical. I don't promote that. I would never promote that. But you can see how they do it. And these are big fines. Remember the flash crash guy in Chicago? And It was 2015, and he lived near London Heathrow Airport. He got fined $36 million, but he did it all using just a retail trading platform called Trading Technologies. So you can imagine the power, because and the wrong person comes in, manipulates the market, and can do that kind of damage where just one trader, one retail trader got fined 30 plus million because of it. It's crazy. And crazy power as well. Anyways, let me rain on. This is a very long video, I realize, but these are the new directions people need to know. Okay, so now we're getting into the nanosecond. Okay, so now we need to understand the clock, this Toronto high resolution clock routine, and there's other ones. Timestamp counter, okay, intrinsic, 64-bit counter, incremented clock cycle. You got to read it. Ingress. So here you go. At the start, ingress, and the end after processing your pipeline. Measure the latency, nanosecond precision, and it's calibrating at the same time. Converting the TSC ticks into nanoseconds. Can you imagine that? Hey, again, throw in the membership. Yeah, got to do it. Do it while it's still affordable. This will get expensive, without a doubt. Okay, so now we're focusing on the binary file. If you're from the Windows world, that's the executable. There's an environment needs to be set up. Again, we're after low latency, but everything becomes non-deterministic. So in here, we got a bunch of scripts that can be used as well. So here, these are examples. CPU frequency set, okay? So at the CPU level, you have these ways to turn it on and off, okay? Have CPU sleep states, okay? Sleeping saves power, but waking up can take microseconds or even milliseconds. Unacceptable delay. CPU isolation. Again, here's some of the techniques here. ISO L CPUs, kernel boot parameters set in the GRUB configuration. That's on the Linux startup. Tells the Linux scheduler to not run any general system tasks on these specific cores, things that you're learning, all courtesy AI. No HS full, disabling the scheduler periodic timer tick on these cores. Helps to reduce jitterness. Disabling it allows the application to run uninterrupted. These are things I didn't even know. Running again, at the kernel level. RCNOCBS, reduce the workload of read-only update, RCU, fallbacks on isolated cores. Okay, so you have to obviously reboot to take over or to reset for the changes to take effect. So here we got VMNR huge pages 2048. So we have those 2048 huge pages at boot. We have swappiness. Reduce the kernel tendency to swap memory pages to disk. So everything's kept in memory. It's a performance killer and should be avoided at all costs for latency sensitive applications that you're trading. Overcommit memory. Configure the kernel memory overcommit behavior, which can be important for applications that manage large pre-allocated memory pools. Okay, so here we're getting now into other ones. So we have syscontrol settings, increase the size of the kernel network of buffers, prevents packet loss during high volume bursts of market data. Interesting, because now this is specific to market data usage. Okay, TCP IP congestion control at the bottleneck bandwidth and round trip propagation time. IQR, transparent huge pages. Okay, so again, I could go on about the nitty gritty here. Okay, so echo never, blah, blah, blah. THP is a system trying to automatically as huge pages for applications, da, da, da. For HFT, it's better to disable THP and manage huge pages explicitly. I bet you maybe in DeepSeek you'll get this kind of knowledge. But this other particular LM, you can't get around it. Deployment and operation. So we have scripting specifically for the production. And it's production ready so that when you go into your CME server environment, you can just tune it to what you need it. Okay. So here we have standard managing services, courtesy of Linux. Generate service file is a master class in configuration. Okay. Define dependencies. Okay. I remember this. This is in a configuration file here. We have a service, user groups, XX, restart, CPU policy for scheduling, first in, first out, with the CPU scheduling priority. System the equivalent of what our C++ code does with our set schedule. I'd be curious to know if Rust can do this. I'm sure it could, but if you're going into career, you kind of want to stay in the world of C++. So here we have iOS scheduling priority, higher IO priority, limit memlock. The process is locked to an unlimited amount of memory into RAM, preventing it from being swapped out, crucial for real-time applications. Man, this AI is good, man. Hardening. This is another big one. Hardening, security hardening. Modern system options that sandbox a service, reducing potential attack surface. That's key. And you could, so the question can be, you could probably run this on a cloud environment as well, just from knowing this monitoring shell script that gets outputted. I've seen it. I kind of played with it, kind of. There's this MD file as well, markdown file, build and run. So you have starting and stopping on that program I told you about, the C++. The journal control provides a real-time stream of application logs, manual execution, running the application directly with tools like task set, primarily set for CPU affinity, and nice to adjust the priority. Again, this is all Linux. Performance testing and validation. Test script that's provided here, rigorous framework benchmarking and application collecting and wealth diagnostic data, performance testing, collect system info for debugging, both at the kernel CPU, if your tests are reproducible. So this goes all out, man. This goes all out. It's not just about coding in your C++. It's configuring both your hardware, architecting the right hardware that you want, as I said, pinning your C++ coding, via the compiler and pinning certain tasks to specific CPUs through the threading. Very challenging, I would think. AI, show you examples. So here's some more tools that's used again at Linux, IOstat, VMstat, SAR, the background where it logs the IO, the disk, memory uses per core CPU utilization. Again, you're going to run rigorous testing on this before you go into production, and then have other configuration to disable this and optimally run with the configuration you want when you go in your live trading environment on something like the CME if you do this. So here we have a profiler, making sure the trading application uses and is concerned with timing out, testing the run on that. strace C on all system calls made by the application. HFT application on its critical path should make very few system calls. Okay, so it's giving you tips on specific to HFT. Performance record G, powerful tool in the arsenal. Sample application call stack thousands of times per second, building a detailed profile where the GPU time is being spent, being wasted, generating all the reports. You get a performance test, human readable performance profile. Here you go. Pinpoint hot functions that need optimization. Analyze the application own log output to extract the final throughput metric. Again, 100% generated by AI. This is mind blowing. All logs reports bundled into a single tar file or tarball archive. You know when you know Linux, when you know that's a tarball, the tar VV format. So now how to interpret the results? So we have here that's generated a performance report text. Examples are provided. I'll show you where to go if you're interested. Showing you where the cycling of the CPUs, optimizing them, time well spent in the core worker loop, not in the library function or system calls. This is why I keep saying you want to eliminate as many tenants as you want, because this is what you don't want. You don't want it to spend time in the library functions and get sucked into something like, dare I say, quantlib. Well, you wouldn't want to use quantlib library in production. I mean, you could use it for research. Yeah, why not? But these are the two hindrances right now in the performance level: your framework library calls and your system calls. So we have here syscalls log, strace, minimal number of system calls during the main processing phase. CPU usage log with SAR. Producer and worker threads are running at 100% on their pin cores. Crazy that you can do that. Isolated cores are not being disturbed by other system processes. So essentially trying to do this in the cloud is, depending upon how low latency you want to go, how efficient you want to go, how high performance you want to go, you have to build this on your own hardware solution and then drop that hardware solution, that box, into the CME and run it within the CME environment. And at the same time, paying for all the feeds that you need and all the blah, blah, blah. So here we have a throughput summary. Bottom line, did the system meet its performance targets? So here's the things again. So we're trying to build this ultra high performance C++ trading system. So it is a journey for bare metal system requirements, as I've mentioned, intricate details of compiler optimization, kernel tuning, and deepen a C++ code that forms the engineer's code. Again, this is why these engineers in these firms, Citadel, Jane Street, get paid millions of dollars for specializing in this. We have demonstrated how to manage the threads, again, at a high level, memory, CPU resources with surgical precision for low latency. And I'll say here, ultra low latency applications. Scripts, C++ code, powerful foundation, capable of processing millions of messages per second. And again, this is key. Deterministic microsecond level latency. Key takeaway: the principles of mechanical sympathy and holistic system design. This is not a feature to be added later. It is the result of thousands of conscious decisions made at every level of the stack. Hardware selection, kernel parameters to niche, cache niche alignment, and lock-free algorithms. Lock-free. Okay. What's missing? This is again specific for a trading firm at an HFT level. Okay, so again, what is missing right here? So we have our modeling, market making, most likely that is the most lucrative, real exchange connectivity. Okay, so we've already talked about that with the CME, ICE. Those are usually one of the two big ones you're going to go with and do the pay to play and all that. So here we can simulate market data, but the real system, we have to interface directly with the exchange using their protocols like FIX or some other proprietary binary protocol. And it's using specialized network cards. And again, in the beginning, I mentioned there are some cards, NICs, NICs, that are recommended. And you could build these and test these for under 2000 with an FPGA board with your NIC and your server, okay, uh, at that level to play with, okay. Then once you go into production, live trading, you want a high level, high regard. And as I mentioned before, London Quant, um, back years ago, he's done amazing. I was on the inside of his mind on what he did. What I will tell you, his investment into Dell back 10 plus years ago, most high end server, rigged right up to the max memory. Each server he bought two, one for himself for testing, and the other one for live trading in the London Conex networks. That were the networks for Forex, which he specialized in for currency trading. And he only focused on one instrument, Euro USD. And he spent $100,000 on each server, one for himself and another 100K for his own, for the production server as well, just so you know. Then we have also the ASICs and the FPGA, latency, critical parts of the logic, where you're using the order book maintenance or risk check, often offloaded from the CPU and entirely implemented in the programmable hardware FPGA or custom chips, ASICs, pushing latencies into the sub-nanosecond realm. Here, you can't do it in software from what it sounds like. I have confirmed there's Optiver video on how they do it. I believe there's an FPGA. Obviously, they're not going to go into specifics on how it's done, but they definitely talk about the high level and how it's done, more at the high level of the architecture. But again, with the LMs that I'm seeing, they can show you if you get right into it. But again, I mentioned it earlier. I have blown up the request. It streams it. The AI will stream it. And then, oh, sorry, there's not enough tokens. Sorry, to generate the code. Okay. So I know it's capable, but you got to pay to play at that level as well in these specific LLMs to make it happen. Cost? I don't know. Placeholder logic in C++ code will be replaced by complex machine learning models. One of the examples and we've not even talked about the machine learning yet. The techniques, one of them had, this one that I'm mentioning is a neural net built in, a basic one. I have seen other types of machine learning as well. So here we're using it for signal generation, parameter calibration. So it's doing it on the fly using AI techniques. And here we go, backed by petabytes of historical market data. So there are options, and each version of the C++ program from the project specializes in each of these needs. So maybe you could split up having separate C++ uh, programs, binary files, whatever you call them, each for a specific need and a specific challenge. And then you drill it down. Once you've gotten everything tweaked and blah, 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 you can then build out your specific binary file for the live trading. This is key as well. Secret sauce stuff. It's not one single algorithm. Everyone believes it's going to be some magical algorithm. No, 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 no. This is what you need. What we've already been talking about in this very lengthy video. flawless, high-speed integration of all of these components. That's the secret sauce. Like I said, one of the examples I posted, I'm not sure if I got it compiling, but it gives you an idea of the three levels of very intricate models that are needed, one for volatility, one for risk, and so on, that are layered together to be able to build out this so-called secret sauce. Okay, just so you know, the framework presented here is essential software blueprint for world-class systems that are built. These are again HFT, top level, most lucrative high frequency trading firms. As I said, one of them, just a snippet of it, came from Jane Street. Don't ask me how I got it, but it was there. Testament to the power of C++ and the Linux operating system when wielded with a deep understanding of the underlying hardware. And again, that changes, it seems, every week. Continuous cycle of measuring, analyzing, optimizing is the true nature of the game in the world of high frequency trading. This right here, this article, and there are going to be people that have not watched this video, 1.5 hours. So let me show you the behind the scenes of the coding examples that I've provided from this very specialized LLM. Okay, so never seen before in public. Go under more. Now I'm already logged in. I'm the guy who does this stuff. So I'm going to show you the file share for the Quant Leap programming. Okay. You'll see the evolution of how this has evolved. So in here, I'll just show you the quant analytics. Okay. We have some high level, bare bone Python C++ projects, but it's not what we're talking about here in this video. This is what we're talking about here. Another C++. Okay. We have here, this is the particular one I'm speaking about, this Ultra HFT system. So if you see this buried somewhere, that's what you look for. This one right here is the ultra low latency trading system as well. This one is not been compiled, built. I just kind of abandoned it, but it does have some coding examples in there on what we're talking about here, the very low grade level, world class coding. This one right here uh, is the market making. Okay. So let me just open this up just as an example. Um, Here we go. So in here, we have a market making system. Okay. In here, you'll see the system in C++. There's an enhanced one. There's a market making system as well. And then there's different README files for that as well. Okay. And then this is market making, but it's specific, well, it's high frequency trading level. In here, I've also made a separate project as well in there for both a back end and a front end, which is JavaScript. But as I said before, and I can verify this across various LLMs, the more features you request, the more, for example, if you want a front end, if you want error uh, messaging and error handling, you're going to water down the quality of the code. Okay. This is why I'm doing it now in iterations so people understand that. Some of these projects work, some of these projects don't work. Okay. Here's another example of arbitrage. Okay. So this one's specific for ZR, which I believe is corn. See if this will open up. Open file. Here we are again. So again, this is what's inside. And again, I'm only posting this available for my Quant Elite folks. This is why it's getting more expensive, showcasing all the different coding techniques. What I just talked about is very high level. Again, here you got the different iterations of arbitrage for corn. I believe there's market making involved in it as well. There's the 2, 3, 4 versions, along with, I believe there is a front end. On top of that, it's a simulation. And then I've added in looping because it's kind of what it is. These are all self contained as well. I just want to make sure that's understood. Because if you look at this one, which I can show you the ultra low latency as an example. Um, I'm purposely doing this at the end of the video, okay, so people like that fully understand this stuff. Believe, well, let's look at this one. No, this one. Let's see if this will get opened up. Nope. We want uh, this one. So in here, you'll see you have the original, that 5 million milli data per second. Okay, that one's specifically talked about in this in this blog post and this video. So you're going to want to look for that ultra HFT system project on the Elite. Okay. In here, it talked about the different scripting. It's where they're talking about deploying production, checking the requirements, build directly, the build CMake as well, monitoring script as well, optimizing and performance testing. So that's all that's been talked about already in this blog post and video. Here's the results. Okay. So when you run them, you will get, I don't know, let's check out the IO stat. I've never seen this before as an example. Let's just check it out. So these are what a lot of these shops will do at the Linux level. You can see here, this is running off a standard commodity laptop. Obviously, when you get more into a high end, you will see performance and metrics that uh, is very useful for the performance tuning as well. Okay, so just low level experiments here. Okay, syscalls, and this is all. Let's take a look at the throughput here as an example, which there won't be obviously, but this is HTTP high frequency trading analysis. I guess nothing was generated. Yeah, 0. VM stat log. Uh, that's across the cores, I believe. It's not a very big. It's like 8 cores or something in this laptop. Here's the system info for those that may want to know. So here we've got a Linux. Now again, this is running in a WSL on Windows, 12th generation Intel. It's got 12 cores, not bad. Blah blah blah. The network, the compiler, all that fun stuff. So these are what these HFT shop operators are looking for to tweak till their heart's content. Okay. So again, these projects are available. I've given you the project. People are going to go, how do I get access to this? Well, there's a couple of ways to do it. As I said, most people that are watching the video will watch this webinar. I may make it. This is going to be not as deep as this video. Can't do it in a short period of time. There's just no way. Okay. Here is where you go under the plan. Okay. This is what the current price is. I had it at $47 last week. And I expected more people to jump on it. And there's a message there. September 2nd, that got closed out on. Oh well, life goes on. So that will go up, and that's annual. Okay, that will go up as I bring in people, and I've got trading shops highly interested in these topics. And again, as they come in, believe me, man, $1,000 per year is nothing. But I will scale it up as we talk about more of these topics and get more into hardware tweaking, OS, Linux, kernel tweaking, and the models themselves. All right. So it's almost 2-hour video, but if you want to start as an example to understand the HFT infrastructure, what a lot of these trading firms are using in their high frequency trading setup, I've got an ebook on that. That was written last year. I have no idea. I think almost 1,000 people have gotten their hands onto it, and it's free. Just got to opt in. I don't really share information as well. Other than that, thanks for watching. Hope you got something out of this very long video. A long video I haven't put out for a while. That's how involved high frequency trading is. True high frequency trading, not this garbage you see on TikTok and the like. Over now. Bye bye.